Late winter in the Northeast can bring a specific kind of structural failure. When a layer of dense, wet snow settles onto heavy dead vines, it creates a crushing weight that can buckle the wire mesh and wooden hoops of a 20-foot chicken run. For a backyard flock, this isn't just a maintenance issue. A collapsed roof creates an immediate entry point for ground predators like foxes and coyotes, turning a secure night shelter into a liability. Most people solve problems like this by treating AI as a digital oracle. They ask one question to one system, take the first answer provided, and assume the consultation is over. But restoring a 10-foot wide span of fatigued steel requires a more rigorous approach. The creator bypassed the single prompt habit and instead built a multi-model consultation team to cross-examine the structural failure from several angles. By treating a physical repair as a structured dataset, the project produced a transparent technical case study. This methodical documentation eventually found an audience of over 1.5 million viewers, demonstrating a new way to integrate digital logic with manual labor. A visual survey captured the sagging hoops and improvised pallet tower. These photos were fed to ChatGPT to identify weaknesses. It flagged the vertical tower, warning that without diagonal support, the column was prone to sudden lateral collapse. This initial diagnosis was then passed to Gemini to compress the raw logic. Its task was to take the various safety warnings and distill them into a clean, prioritized framework for the rebuild. The final prompt went to Grok, which was tasked with producing a field-ready execution guide. This provided a highly specific, step-by-step sequence for the physical lift, perfectly tailored to the exact materials on hand. All three systems reached a consensus on the first move. The foundation had to be locked. To prevent the tower from racking, diagonal cross-bracing was required to triangulate the support before any upward force was applied. This multimodal approach is a safety check against hallucinations. When three distinct systems converge on the same structural requirement, it provides a level of confidence that a single prompt simply cannot match. To manage the lift without kinking the metal hoops, the panel recommended moving away from improvised levers. The technical solution involved steel jack stands or a small bottle jack to provide the controlled, incremental pressure needed for a fragile frame. Instead of heading to a lumberyard, the creator audited the property's existing materials. This inventory showed stacks of weathered dimensional lumber and a substantial pile of brush and branches available for the rebuild. They specifically selected a straight, thick branch from the brush pile to serve as a load-bearing ridging. By using a foraged material that already matched the length of the run, they created a permanent interior spine at zero cost. The lift followed the AI panel's safety constraints exactly. Working in half-inch increments, they slowly raised the peak while monitoring the tension on the wire mesh to avoid kinking the fatigued metal. This process highlights a parallel between the physical and the digital. Sourcing a branch from a brush pile is the manual equivalent of foraging across intelligence platforms to find the exact insight needed for the job. The result is a structurally sound run with a new, steeper pitch designed to shed snow before it can accumulate. The fatigued hoops are no longer under tension. They are supported by the interior ridge beam. This illustrates a repeatable methodology, the SDP cycle. Sense translates the environment into digital data. Document synthesizes that data through AI into a cross-checked plan. Publish is the simultaneous execution of physical repairs and distributing the technical documentation. These tools provide a framework for engaging more deeply with our physical surroundings. By using them to solve and share our projects, we increase our capacity to navigate and repair the real-world reality